class, right triangles is the name of the game in this section, but we're going to come back to, I know this is the front page of your note packet, but looking back on it, I kind of want to review a little Pythagorean theorem first. So let's recall that the Pythagorean theorem is a squared plus b squared equals c squared. Okay, a and b are the legs of the triangle. That would be, in this case, this side and this side. And then C is the hypotenuse. Okay. Hypotenuse is always the longest leg. It is opposite the right triangle. So when we set this up, we're looking for this side right here in this particular problem. So we would say 4 squared plus 12 squared equals c squared. Now, I'll do this piecemeal, but you probably can do this in your head. This 4 squared is 16. This is 144 equals c squared, and 16 plus 144 is 160. Now, when we take the square root, you're going to have to remember all of those times I told you you're taking the square root of an equation, you put in the plus minus, and you're going to throw it out the window. I'm just kidding. Don't throw it out the window, but let's think we're talking about the length of a triangle. Lengths, for our purposes, cannot be negative, so we'll just do the positive value. But exact solutions only in this unit. So we're going to actually have to recall our method for simplifying square roots. Create the factor tree. So I'll do 16 and 10. And I'll do 4 and 4, 2 and 5. And I'm actually going to stop there and consider why I'm stopping there. Okay. 2 and 5 get boxed. So we end up with 4. And then 2 times 5 would go back in and give me 10. And again, don't need the plus minus because we're talking about positive lengths. Okay. Now on this triangle, notice this time we're looking for a leg. Okay. So we have to be careful. It's a squared plus b squared equals c squared. Make sure x is either a or b. Now, typically a is thought of as the shorter side. I'm not that picky. We can put in x for a or we can put in x for b. It doesn't matter because you're solving for a leg. So x squared plus 14 squared equals 20 squared. So x squared, oh, not plus, or not equals, plus. All right. Plus 196 is equal to 400. We'll subtract 196. See, subtract 200 would be 200. It would be 204. We got x squared equals 204. I'll take the square root. Okay, so 204, let's create our factor tree. We got, I think it's 4 and 51. This breaks down into 3 and 17, and this into 2 and 2. So we got our pair of 2s. We got our 3 and 17. So it ends up being 2 times root 51. Again, exact solutions only in this unit. Okay. So go ahead and see if you can give this one a chance. All right, so again, we're finding a leg. So writing it out, a squared plus b squared equals c squared. All right, I'll put in square root of 8 there, and I'll put the p in for b. And then root 26 squared. Now we've done this calculation enough to recognize that square and that square root are going to cancel. So we wind up with just, and if for some reason you forgot that, you're probably going to type it into your calculator and you're just going to get 8 and 26. So we subtract 8. We got P squared equals 18 square root. Now this one's a little bit nicer to find because we got 2 and 9, 3 and 3. We got our pair there and our root there. So P equals 3 root 2. Now, the primary reason I wanted to start with this is to remind ourselves that in right triangles, the Pythagorean theorem is very specific that if we have two of our sides and we're looking for the missing third side, what the length is, we have a process to do that. We have a relationship between the three sides of a right triangle if we need to find unknown lengths. Okay. Oftentimes, you guys like to ask me, when am I going to need to know this in real life? Well, finding unknown lengths is a very common application in many real world problems. Where SOHCAHTOA comes in is, what if I don't have two sides? What if I just have one side and I have an angle? Say I had this angle and this side. Okay. They're variables now, but what if they were not variables? What if they were actual lengths? Can I find everything else in the triangle? The answer is yes. This is where trigonometry comes into play. So let's remind ourselves that we have a theorem in geometry where the angles of a triangle add up to be 180. So this one right here would just be take 180 minus these two angles. That's good. And now the trigonometry demonstrates how do we relate sides and angles together. So what does this mnemonic stand for? So I'm going to write it out a little bit further. I'm going to spread it out. So the first letter of each of these groupings stands for the name of a trigonometric function. The S is sine. The C is cosine. Okay. The T is tangent. Tangent. No. That's supposed to be a G. Yikes, I must have written that out a million times in my life. I've never spelled it with a G before. Tangent. There we go. Okay. But I'm seeing some O's, I'm seeing some A's, I'm seeing some H's. Well, the easiest one to get out of the way is H is the hypotenuse. We just got done talking about hypotenuse. We're talking about right triangles. We're not going to stop talking about hypotenuse. Okay. So hypotenuse would go there. Okay. I'm actually going to change this A now to an O. The reason why I'm going to change it to an O is because given the angle I've marked, that side is the opposite of the given angle. Okay. And then the A, so this would be H. The A would be adjacent. So this is opposite. Now, all I've done so far is write a bunch of words on a page. What is this all supposed to represent? What is this all supposed to mean? And it goes back to that idea I talked about how do sides and angles represent? And then you've been probably screaming at your computer screen for the last few minutes. What is this right here? This little zero with a line through it. This is theta. When you get into trigonometry, you start to get into the Greek alphabet. And, oh, no. Oh, well. I don't know how to undo that with this, so we're going to have to let that be a permanent mark in the video. But the Greek alphabet, and it's a Greek letter theta. So this is how we would set up our problems. We'd say sine of the given angle, in this case theta, is equal to the opposite side over the hypotenuse. So the sine of an angle is equal to the ratio of the opposite side over the hypotenuse side. Okay, and that's how this mnemonic is supposed to help us remember: sine, opposite, hypotenuse. So if I told you cosine, we'd say it's equal to the adjacent over the hypotenuse. It's the ratio of the adjacent and hypotenuse sides. Okay, and then we've got tangent, which you might have guessed is the opposite and adjacent sides. Okay, now those are the three primary trig functions. There's actually three more. There is cotangent, there is secant, okay, and there is cosecant. Now the mnemonic is only going to help us remember these first three. You have to do a little bit of work to remember these last three, but luckily I think they're easy enough to remember. So cosecant is equal to the reciprocal of sine. So I'm using that word specifically, reciprocal. The reciprocal is when you take the fraction and flip it. So the cosecant is equal to the hypotenuse over the opposite. Okay. Secant is equal to the reciprocal of cosine. So I'm taking that ratio and I'm flipping it. Hypotenuse over adjacent. And then by process of elimination, that means that cotangent is the reciprocal of sine. I'm just kidding, it's tangent. So we take that opposite over adjacent and we flip it. So again, sine, cosine, and tangent. Take this mnemonic with you everywhere, and you'll have no problem remembering how to set up these ratios. Cotangent, secant, and cosecant, you just have to remember which one are they the reciprocal for. Cosecant is sine, secant is cosine, and cotangent. That one's a little bit easier to identify. Cotangent and tangent. All right, so let's see what this looks like. Now, keep in mind, this all has to do with what's called a reference angle. And the reference angle will always be given to you in the problem. And you're going to be given it in the drawing. So we've got our reference angle here, theta. And I always like to draw my arrow across from it because that reminds me what the opposite side is. So we're not mixing up. The hypotenuse is easy because the hypotenuse is what's always been. It's opposite the right angle. The opposite side is what side is across from the reference angle given to us. So this is a given the right triangle, set up all 6 trigonometric ratios. We're just doing straightforward, simple stuff today. We're not solving any problems. We're just setting up problems. So I start with sine theta. So writing out my mnemonic, so ga toa. I know sine is this first one, opposite and hypotenuse. The best way to remember which one goes on top in the fraction, opposite comes first in the mnemonic, so that means it's going on top. So my opposite is 8, and my hypotenuse is 17. So that's 1 out of 6. Let's do cosine. Cosine, the C, is adjacent over hypotenuse. So adjacent is next to. Now, hypotenuse is also next to the angle, but that's already got its own name. So we call this the adjacent side, is 15. And then again, our hypotenuse is 17. And then tangent theta. Tangent is opposite over adjacent. That would be 8 over 15. All right, that's setting up the trig ratios. Now that's 3 of them. We got to do all 6. So let's talk about the other 3. I like to help myself remember which one is the reciprocal of which by writing them right next to each other. So cosecant theta, the fact that I'm writing it next to sine helps remind me that I need to take the reciprocal. This can be a bit dangerous. If you write it next to the wrong one, you might invert the wrong one, but cosecant and sine. Each pairing, one should have a co and the other one won't. So cosecant and just sine, whereas this one is cosine and secant. Okay. Secant would be the reciprocal of cosine, so that would be 17 over 15. And then cotangent of theta, reciprocal to tangent, is 15 over 8. And we're done. Go see if you can try this one on your own. All right, so let's look at our reference angle T. And again, our opposite side is that 33. So instead of theta this time, we're just going to use a good old-fashioned English alphabet T. We'll start with sine of T is 33. Oh, yeah. Let me write the mnemonic at top. Sine is opposite over hypotenuse, so that's 33 over 65. We got cosine of T, 56 over 65. And then tangent of T would be opposite over adjacent. That'd be 33 over 56. And then we can set up cosecant of T. That's the one that's reciprocal to sine. So that's 65 over 33. We have secant T. That's the one that's reciprocal to cosine. So that's 65 over 56. And then we have cotangent T is the reciprocal 56 over 33. All right, let's go over these last type of problems. I like these problems because they are problems that kind of take everything we've talked about to this point and kind of sums it up. Now, notice we're not given a triangle. We're just given one identity of sine. So we have to try and figure out what the other 5 are. Okay, so instead we're going to construct our own right triangle. I generally like to kind of just have a single construction for the right triangle. How you draw it is up to you. I always draw mine like this, and then I always label this one is theta. Okay, I shouldn't say I always draw it like this, but more or less. Okay, now remember with SOHCAHTOA, this is opposite. So what side would that be? That would be this side right here. And then this is the hypotenuse. So this is 7 and this is 10. But notice that doesn't give us what the adjacent is. And we're going to have to figure out the adjacent by using, you guessed it, Pythagorean theorem. So that would be 7 squared plus b squared equals 10 squared. We get 49 plus b squared equals 100. We're going to subtract 49, but in the interest of space, I'm not going to write it out. 51, and then square root it. 51 does not simplify, so it does not simplify out a perfect square, so just square root of 51. Okay. So when we're setting these up, let's start with sine, even though sine was given to us. Let's make sure we just have all of them under one umbrella. Notice you're given one. You can figure out its reciprocal automatically without having to actually draw the triangle. So you're given one and you're kind of given a second one. So now we just have to work out the rest of them. So cosine theta was the adjacent, which is root 51 over 10. And then we can write our secant if you want to. Take a little bit of a shortcut and then find the reciprocal of that. Okay. And then we've got tangent. Tangent was opposite over adjacent, so that's 7 over root 51. And cotangent, theta, it would be the reciprocal root 51 over 7. Go ahead and see if you can work this one out. Okay, so cotangent. Now let's remember, so we're not actually given one of the three primary ones in our mnemonic. We're not given sine, we're not given cosine. Oh, so ka, toa. But we are given the reciprocal of tangent. So if we refresh that tangent is opposite over adjacent, that means this would be adjacent over hypotenuse. Now, when we write out our final answer, cotangent theta is 15 over 14. Again, before we even write out our triangle, we can figure out the reciprocal of that one as well. You just have to remember which one it is. In this case, it's tangent. So, and in this case, we can use that to help draw out our triangle. We have theta here. Again, we have our opposite here. Not adjacent and hypotenuse, adjacent and opposite. I apologize. It's been a long one. Adjacent and, oh boy, pen doesn't want to cooperate. I apologize. While we figure out these technical difficulties. There we go. Opposite would be 14 and adjacent would be 15. So again, use your Pythagorean theorem. This one's a little bit more straightforward because we don't have to subtract this time. So we've got 225 plus 196. See, that'd be 425, 421. I'm just rolling with it. The square root of 421. So, and that doesn't simplify. I'll kind of save us a little bit of time on that one. That's just square root of 421. Okay, so now we're free to set up the sine. Sine is opposite in hypotenuse. That'd be 14 over root 421. Okay, we can get cosecant at the same time. That would be root 421 over 14. And then we can use our cosine. That would be 15 over root 421. And then secant would be root 421 over 15. Go ahead and give the exit a try. Take it a try. Thanks for watching.